Hello and welcome back to AGT STEM. Today we're going to be watching a video about vanadium. So, without further ado, let's hop to it. This seems very dramatic.
Vanadium, element number 23, the third of the so-called transition metal. So it lies between titanium and chromium in the periodic table. I don't know a huge amount about the chemistry of vanadium. I've never actually seen vanadium metal, so let's have a look at it. It's in a really quite historic box. It's wire. It's not easy to open.
Look, it's very fancy. We've got a very old box with some vanadium wire.
And you can see there's a coil of fairly blackish coloured.
It looks very similar to the titanium from I think 2 videos ago.
Wire. There's several things that interest me. First of all, that you can make wire
I think actually last video.
As thin as that. And secondly, that it doesn't look very shiny. Possibly it's got an oxide layer on the surface. I've been given another sample of vanadium powder, but vanadium powder can catch fire quite easily, and so I don't really want to take it out because
Must be dangerous. I guess that's why they've taped it shut.
we might have a fire here on the table in my office. Vanadium metal is quite light, and it is used in a variety of alloys. It is also like many of the transition metals. You can have different so-called oxidation states with different numbers of electrons around the vanadium atom. Now there's a really nice demonstration which you should watch carefully because it's what our first year students do. So if you
We have to pay attention. Very close attention.
come to this university and several others, if you know this, you'll get better marks in your practical. Darren, my colleague, really enjoys doing this reaction.
Vanadium 5. It's a yellow solution of ammonium metavanadate. As you can see, it's a nice yellow colour. And one of the really nice things about the various oxidation states of vanadium is that they're different colours. So what we have here is we have a metal amalgam. And this is mercury. As you can see, we have mercury with some zinc in it. The really nice thing about this amalgam is that we can convince some electrons to jump from this metal amalgam onto some other species. So remember, vanadium 5, and I'm going to put in here a glug of vanadium 5. That's not a scientific quantity. That's a glug it's a good glug. The vanadium solution is sitting on top of the mercury zinc amalgam, and hopefully what I'm going to do is, by shaking it up, I'm going to convince some electrons in the metal to jump onto the vanadium species, changing the oxidation state of the vanadium. As I do it, hopefully we'll see a colour change. Can you see the yellow?
Yeah, I can, yeah.
Alright, so let's see. So now, a nice blue colour, right? And the blue colour, I happen to know, is...
It's like a rainbow. It's like it went from yellow to blue, or to green to blue.
Vanadium 4, right? So each of the vanadium species has gained 1 electron, changing its oxidation state, or it has been reduced. So if I shake it a bit more, I'm going to see, can we convince more of the metal to give up electrons, right? So I think we're looking for a nice green colour. And you can see we've got a kind of a green colour there. Can you see that as green? We've gone from vanadium 5 to 4 to 3. Okay, so now I need to shake it up a lot to see, can I convince another electron to go and access vanadium 2. So let's see. This is because mercury is so heavy. This is slightly hard work. So there we go.
Wow.
Purple.
That's very pretty. It's so cool looking.
Vanadium 2. So we've gone Vanadium 5, 4, 3, 2. 4 different oxidation states of vanadium, resulting in the really nice purple vanadium 2 species. And then what would happen is, if we put that on the bench and left the lid off, oxygen can obviously, the air can get into the container, and what will happen is we will oxidize this solution again. So if we waited for long enough, we would see the colours go in reverse.
You can find vanadium in nature.
That was a pretty cool experiment. It's just like completely changed colors.
There are mushrooms, the sort of red ones with white spots that fairies and elves sit on in fairy tales. I never know the difference between mushrooms and toadstools. The things that grow in forests. And in this mushroom, or maybe toadstool, nobody's quite sure why there are vanadium compounds. One idea is that it just may be a poison to discourage people from eating it. Or not people, but animals, slugs, worms. The other theory is that the vanadium may react with hydrogen peroxide, which can sometimes be formed in biochemical processes and which would otherwise attack more important molecules to the life of the mushroom or toadstool.
That's pretty cool. So the vanadium could either be a poisoning method to prevent things from eating it, or it could be to help the life of the mushroom or toadstool. He's not really sure. I think that those are toadstools because you always see people sitting on them. Mushrooms would probably be too squishy or flimsy, I should say.
But I think it's really quite interesting that
I agree. It is interesting.
a mushroom or a toadstool can do good vanadium chemistry. Blow up balloons of hydrogen.
Thank you so much for watching. We'll see you next time. Stay smart. Bye!